In this video, we're going to find the area inside of a polar curve with one curve. We're trying to find the area of one petal of the polar rose curve, r equals 3 cosine 3 theta. Well, that will give us a picture roughly looking like this. It's a 3 rose petal curve, and we're trying to find the area of one petal. Well, in trig, we learned that the formula for area in polar is half r squared theta. In calculus, that becomes area is half the integral from alpha to beta of r squared d theta. And if we think about that like a Riemann sum, remember, we're adding an infinite number of itty-bitty slices to fill in this area. So theta, our angle, our central angle, is changing, and r is following along the path of the curve of the petal. So we're going to need to find these angles because that would be alpha and beta. So to do that, we need to do just a little bit of trig solving. So we're going to go 3 cosine 3 theta is equal to 0 because we're looking for the x-intercepts. We can now go cosine 3 theta is equal to 0. And if we pretend temporarily that 3 theta is really theta, we can use our special value knowledge. Cosine is 0 at pi halves and 3 pi halves and so on. So if 3 theta is pi halves, then theta would be pi 6. So now we know in quadrant 1 that this angle is pi 6, which using symmetry makes this angle negative pi 6. So we have two ways we could actually do this problem. One way is to do the top half of this rose petal and double it, or the other way is to do the entire thing. I'm going to go ahead and start by going area is equal to. I'm going to take the approach of doing the top half and doubling it. So I want to double what I'm doing, and I'm going to use our formula half the integral. Now if I'm only doing the top half, then the angle I'm going to be using is 0 to pi 6. So 0 to pi 6 of 3 cosine 3 theta squared d theta. Now that would be top half and double. If I don't want to do that, alternate, we could just do the whole thing and say area is half integral from negative pi 6 to pi 6 of 3 cosine 3 theta squared d theta. So it's your choice which way you would like to do that. So if we take a look at this on our grapher, realize that we have to change our mode. So we must be down in polar mode. So let's get ourselves into polar mode. When we do that, when we go to y equals, it's now r equals. So if I type in 3 cosine 3 theta, and I graph that, I get my polar rose. So there's my polar rose. And now if I want to integrate, we're just going to go math 9. And again, I'm going to take the approach of doubling it. So in this case, these 2's would cross out, so I don't need to put anything in front. If I was going to take the alternate approach, then I would need to make sure to type in a 1/2 or a 0.5 in front. So now I'm going to go from 0 to pi 6, pi 6, and I've got parentheses 3 cosine 3 theta, and I'm going to want to square that d theta. And if I punch that in, then I get my answer of 2.3561944.9. Remember, go ahead and put in that entire value. Now, again, an alternate way to do this problem If they did not give you your calculator, you could go ahead and square that out. You'd end up with a cosine squared 3 theta and a 9, and then you'd have to reduce that with the cosine squared formula. I'm not going to do that in this video, but if you did, you would end up with, I believe, 3 pi fourths as your answer.